Express cos 2x minus cos 6x as a product and hence evaluate the limit of 5x squared over cos 2x minus cos 6x as x approaches 0. Okay, so if we sub in 0 in place of these x's, we end up with 0 over 0, which is indeterminate, which means we cannot determine the limit. So we have to rewrite our function. So cos 2x minus cos 6x is going to become minus 2 sine 2x plus 6x over 2 sine 2x minus 6x over 2. And we got that from our formula, which is in our formula book, which states that cos A minus cos B is equal to minus 2 sine A plus B over 2 sine A minus B over 2. So the reason that this is equal to this is seen in detail in our trigonometry chapter, but for the moment you just have to know how to convert one to the other. So the A is 2x, so we end up with 2x plus the B, and then 2x minus the B, so 2x and 2x, and the B is 6x, so you're adding the 6x and then subtracting the 6x. So 2x plus 6x over 2 and 2x minus 6x over 2. And don't forget you've got the minus 2 in front. So we bring down the minus 2 and the sign. 2x plus 6x is 8x. 8x divided by 2 is 4x. And then you bring down the sign. 2x minus 6x is minus 4x. Minus 4x divided by 2 is minus 2x. Now again, from our trigonometry chapter, we cannot have a negative angle inside of our sign. So this is a trig identity that is from our formula book as well, which states that sine minus A is equal to minus sine A. And again, in our trigonometry chapter, we go through why this is in detail. So the minus basically just comes in front of the sign, and we now have positive 2x inside the brackets. So that's really minus 1 sine. So minus 2 by minus 1 is positive 2. And then sine 4x multiplied by sine 2x, we just stick them together. Sine 4x, sine 2x. So we have 2 sine 4x, sine 2x. So this becomes this. So now we have the limit of 5x squared over cos 2x minus cos 6x as x approaches 0, becoming the limit of 5x squared over 2 sine 4x sine 2x as x approaches 0. Okay, so now we need to rewrite this so that we can use our special trig limit. So we need to break it apart. So here's our rough work. So we start off with 5x squared over 2 sine 4x sine 2x. And we're going to multiply by 4 over 4, which is really 1, by 2 over 2, again, which is really 1, and by 1 over 1. And then we're going to rearrange all the different parts of our fractions. And also note that 5x squared has been broken up to be 5xx. So I'm going to take the 5 from my numerator and the 2. So I've got 5 over 2. I'm going to take one of the x's here and this 4 and stick them together. So I've got 4x in my next fraction. And I'm going to bring down the sine 4x. So now I've got 4x over sine 4x, which I know will end up giving me 1. That's my special trig limit. Then I'm going to take the other x that I didn't use and the 2 and stick them together. So I've got 2x. And then I'm going to take that sine 2x and bring it down. So I have 2x over sine 2x, which I know will give me 1. I still have this 1 left over. So I bring that down here. And then I have the 2 from the front and the 4. So I have 4 times 2. And I know there was a 1 left over that we didn't use, but you could just see it as 4 times 2 times 1 if you want. So 5x squared over 2 sine 4x sine 2x becomes 5 over 2 multiplied by 4x over sine 4x multiplied by 2x over sine 2x multiplied by 1 over 4 times 2, which is 8. So that's exactly what we have here. So 5 over 2 stays as 5 over 2. 4x over sine 4x becomes 1. That's our special trig limit. So look at the special trig limit video if you're not sure where that comes from. 2x over sine 2x again becomes 1. And then 1 over 4 times 2 is 1 over 8. And multiplying, we get 5 over 16. So the limit of 5x squared over cos 2x minus cos 6x as x approaches 0 is 5 over 16. So this is the formula that we used. So this is part of our sums and differences to products. So going from sums and differences, so adding or subtracting to products, which means multiply. So we had a difference, and then it became a product where we're multiplying. That's on page 15 of our formula book. And we also use this trig identity, which is sine minus a is equal to minus sine a, which is on page 13 of our formula book.